In order to analyze a function, a rational function, you cannot approach it the way we've done it in the past. Some of you turned in this assignment, and I sent it back to you because you simply put in what we put in before. The domain, oh, it's all real numbers. The range, it's all real numbers. What are the end behavior? It goes to negative infinity, positive. No, none of that is true. You have to take stock of what that looks like. How do I take it apart? You have to know what the graph looks like. I went ahead and did this for you. This was the first or second graph that we analyzed in class that you have in your notes, or should have in your notes. Go back and look it up. If you didn't, it's actually on the first page of section 2.6. It's right there in detail. Okay? Some of us found that, and you copied exactly what you saw, including all the math symbols and stuff, which was fantastic. You figured out how to put math equations in, and it looked great. In order to do this, you have to be able to look at the graph. Okay? So if we graph this, what is that minus 2 going to do to my graph? Shifts it 2 to the right. So it looks like 1 over x, but it shifts it 2 units over to the right, and then that's exactly the same thing. So if we look at the graph, you should get this. A vertical asymptote here. How do we know that? Set the denominator equal to 0. What do you get? X equals 2. Listen to me very carefully. An asymptote is a line. If you don't tell me x equals or y equals, I'm going to mark it all wrong. I don't care that you got the number right. You need to put it in the right form. Because if you tell me it's 2, well, I can find 2 different locations for the number positive 2. If you don't tell me which is which, then I can't decipher what your answer correctly is. So put your vertical asymptote in. What's my horizontal asymptote here? Why is it y equals 0? The degree on bottom is larger. What's the degree on the bottom? And the top? No x's at all. 0. 1 means there exists an x to the first power. An x to the 0 power is just the number 1. Okay? So if you graph the horizontal asymptote and then you graph the curves, they look like this. Just like 1 over x, but shifted over just a little bit. Does that make sense? Go ahead, Katie. Okay. The question was, if you have an x minus 2 on the bottom, okay, and a 1 on the top, the rule says this: if the horizontal asymptotes, well, if the degrees are, and there's 3 different versions. If the bottom degree is larger, listen, if the bottom degree is larger, y equals 0 is automatically the asymptote. If the degrees are the same, then you divide the coefficients, and we'll see each one of these today. If the degree is larger on top, no horizontal asymptote exists.
So wouldn't it be the degree is larger on the top?
Right, that's why we have a horizontal asymptote right here at 0. Okay? Now, all of these things are all interconnected. Like, whenever you do an analyzation of a rational function, you have to do the asymptotes first, because they're going to affect 5 of the 8 pieces that you're going to write down, okay, or in some way, shape, or form. What's the domain of this? No. 2. Where's my vertical asymptote? So that means that vertical asymptotes affect the domain. It means that that number for x can't exist on the graph. Because if I were to plug it in, it would make my denominator equal to 0, and that's undefined. That can't ever happen. That's why you set the denominator equal to 0 to find your vertical asymptote. Write the domain down. I meant range, not domain. It's all reals, but y is not equal to 0. Can you guess what affected the range? The horizontal asymptote. Okay, let's talk about continuity. I thought you meant no, I'm not going to. I thought, oh, dang. It's not continuous, but if you tell me it's not continuous, you have to tell me where it's not continuous. Where does it break? Where does it jump over? I'm talking about continuity, so I'm talking about x-axis, never y. It's 2. Okay? So if you write out continuity, and I've seen several of you write it out in 2 different ways, and both are acceptable. This graph is discontinuous at x equals 2, or sometimes people have said, well, x is continuous from negative infinity all the way up to 2, and it's continuous from 2 to positive infinity. That's a little bit more involved, but still accurate. You're telling me it's continuous in 2 places, but broken in the middle. That's still discontinuous. Okay? I think it's easier just to tell me where it's discontinuous. Okay, but sometimes it makes more sense for people to think of it the other way, which is fine. But here again, everything we've listed so far has been affected by that asymptote. One or the other. Okay? What about increasing and decreasing? Let me make a major suggestion. There is a little bit less than 5-minute video on just increasing and decreasing. Some of you, it changed your world in this class if you watched it. Okay? Because you can't get the increasing and decreasing right no matter how hard you try. You won't come ask me about it, but every time you do it, it's backwards, or you get one part right, but you miss the other part. Okay? That was one of the things I tried to comment on the homework assignment. You got the increasing and decreasing. Go back and look at it. Imagine you're walking along the curve. If you're going down, it's decreasing. If you're going up, it's increasing. But here's the trick. You have to go left to right, which is not the same as in behavior. In behavior, it goes 1 to the left, 1 to the right. Increasing and decreasing is all the same direction. Because if not, then I can make it go any way I want to. I'm just going to go the direction I want. And there's no correct answer. So when you're going across, watch the curve. It's going over. What's happening to the curve as I go to the right? It's going down. What about the other side? As I go to the right, it's still decreasing. 2 decreasing intervals. Negative infinity to 2. And then again from 2 to positive infinity. It's broken.
But it's not touching 2, so why wouldn't it?
Did you put a bracket at 2? You never touch 2 anyway. That's why we don't use brackets in increasing and decreasing. Just parentheses. Because technically speaking, at one specific point you're standing still. You're not actually going up or down either way. You don't include a point. No. For increasing and decreasing, I'm telling you to put parentheses only all the time. Because in my book, at a specific point, you're stopped. You're not moving at all. Okay? So here's what it should look like. In your book, it uses the union symbol. Okay? Some of you freaked out about that. It's okay. Okay? Union, that's the symbol for you. Sometimes you'll see that written in between things. It means or comma. It's just a math term for this one or that one. Or take this part and take this part. Let's put them together and talk about that as my whole answer. Rather than everything all in a unified answer. If you see that upside down, it means and. The intersection of those 2 points. Not that you need to know those. You don't have to use that. All right, next. Symmetry. What do you think symmetry is? Why neither?
Because you can't flip it 180 degrees and it look the same.
Why? What if we flipped it 180? What would it look like?
Maybe on the opposite side.
Oh, I think I can do this. Hold on. Let me see if I can flip it. Okay. There you go. I just flipped it. Is it in the same place? Totally. What's my asymptote now? It's negative 2.
So if the asymptotes were 0, 0, then it'd be odd.
If your asymptote, if your graph, if that central point where the asymptotes intersect, if that's the origin, I'm good. I'm still odd. That's just like 1 over x. But when you move that away from the origin, well, that goes up, down, left, or right. I don't care which way it moves. You lose its odd symmetry. Obviously, because we just turned it over, and I'll turn it again. This is awkward. That's not entirely right, but oh, that's going to bother me. No, that's crooked. There we go. Okay? That's on the other side. Right? No? Whatever. So, people thought it was odd, but in fact it is not odd. It is neither. Asymptotes, we've already mentioned these a couple times. What about extrema? Do not include infinity as extrema. Infinity means unlimited. So there are none. Good. Okay, what about in behavior? Uh-oh. I sent a world of papers back for this one. As this graph goes out to the right side and to the left side, where does it go? To 0. Okay? And so we have in behavior that looks like this. Okay? Your vertical asymptotes and horizontal asymptotes, other than the extrema and the symmetry, and of course the asymptotes themselves, that's kind of redundant, everything is affected by them. That's why you've got to find them first. Otherwise, you can't do the rest of the problem. Does that make sense?
Mr. Whitting,
Sir?
how do you find out extrema again?
Maximum or minimum? In some respects, if I gave you a problem like this and asks for that kind of analysis, I probably would give you the picture of the graph. So most of the time, it's going to be a no max, no min. Yes, sir. What?
Why is it 0?
Why is what 0? The limit in behavior? Okay. Look right here. As you go to the left side, right? This graph is getting closer and closer and closer to what number? 0. As you go to the right side, the graph is headed downwards, closer and closer to what number? 0. I mean, this is an exaggeration, right? You got this graph, it's going up here, it's going down, down, down. It doesn't matter how far you go. It's a limit. That graph will never breach 0. It'll never touch it, but it'll get as close to it as infinitely possible. Okay? If you go down this other side, it's the same process. This is coming from the top side. One's going from the top, one's coming from the bottom. Does that make sense? So, with in behavior happening, which asymptote affects in behavior? Your horizontal asymptotes. So if you don't have asymptotes, then your in behavior happens to generally be positive or negative infinity. For the most part, not always. Let's try another one. All right, you do this. This is just asymptote practice. Got 2 examples.
So what if it's the same?
Do what?
What if it's the same thing?
That's what you have to figure out. All right, try these. All right, so when you go through all this process, you've worked them all out. When you find the slanted asymptotes down here, okay, you do long division. Do whatever it needs to do. You take the bottom part, you divide it into the top part. Whatever happens to end up on the top, your quotient, that's your slanted asymptote. The remainder, you drop off. You disregard it. Don't worry about it. it will always end up a line. A single line. If you get an x squared or an x cubed, okay, or anything like that, it means that that's not a slanted asymptote. Okay, a slanted asymptote is still a line, it's just not vertical, it's not horizontal. Okay, a graph, a slanted asymptote would look something like, so if you had a graph like this, you can have a kind of something that looks like this. Okay, you could have an asymptote like that would change it, and you could have all kinds of things. You can have asymptotes, two different asymptotes, different values.
Why do you disregard it?
The remainder won't affect the asymptote. It affects the graph, but what's the line that gives me the asymptote? That's what's on top of my function here. Shh. What? I don't know. No, the 9x is just part of it. The remainder part, if you take the limits, it has to do with limits. You take the limit of that. This is calculus, by the way. X plus 9x over x squared minus 9. Look at that. If I let x get incredibly large, what happens to the second part of this function? The bottom part is going to get way bigger than the top part way faster, which means that fraction, as x gets bigger, that fraction gets smaller and smaller and smaller and smaller, and eventually it's so small it doesn't have any effect. But what doesn't get smaller? That stays constant in whatever x is. So the fraction disappears and you're left over with just x, but that you don't need to know. Jeremy?
How did you know that there was no horizontal?
The degree on the top is bigger, no horizontal. It's always the case. One more. Try this. In terms of time, what I want you to do is find the asymptotes. Think about domain and range. I want you to think about in behavior. If we get to do more, we'll go further. But for now, do those things. Shh. All right, here we go. Horizontal asymptotes. Shh. Why is the horizontal asymptote 0? Y equals 0? Shh. What's the rule? What? When the denominator is larger, the degree is larger, it's y equals 0. Done. Right? How do I find my vertical asymptotes? Set the bottom equal to 0. Listen, you can have any number of vertical asymptotes. I'm not asking you to graph this. Not right now. Okay? You could have any number of them. If you had a cubic equation, it's possible to have 3. If you had a fourth power equation, you had a 4. Okay, set that bottom equal to 0. That's why we had to do those first before we got to this lesson, because you have to be able to factor and to find roots of things that sometimes aren't that nice. Okay? So we literally set them equal to each other, or not set them equal, but set them equal to 0. So you get 3 and negative 2. I'm glad. What's the domain? Titus? What's the domain? Which asymptote affects our domain? Which one has x equals? Since the domain has to do with x, so it's x is all, or domain is all real numbers except x can't be 2 or negative 2 and can't be 3. What's the range?
All reals equal 0.
All reals except y can't be equal to 0.
Cannot.
Does that make sense? What about in behavior? What are they both going to?
0. Actually, no. It's not.
They're both going to 0.
Yes, that's correct.
Why? I have one horizontal asymptote. Therefore, they're both going to 0.
The horizontal tail.
If I had 2 horizontal asymptotes, can't have any more. It is possible to have 2. Look on the board. Okay, you see the graph, the bottom one? This is a graph of a logistic equation. It is one type of our 12 basic graphs. Shh. It is one of the only ones, not the only, but one of the only ones to have 2 horizontal asymptotes. It means it has 2 end behaviors that go to 2 different numbers. Typically, we don't have that with these kinds of functions. Questions?